So today's lesson is going to be on integration by parts. So just to do a quick review, we've done a couple methods of integration. The basic power rule, for example, the integral of e to the x dx. That one's quite simple. It's just e to the x. And then, of course, you need to add your constant for indefinite integrals. And then we changed this up a bit and did something like this. X times e to the x squared dx. And this was our substitution method that we did in the previous lesson, where you can notice that, well, the derivative of x squared is 2x. So you can make a substitution where you say u equals x squared, and so du equals 2x dx. And so this integral just becomes 1/2 the integral of e to the u du, which we can do based on our first example, which would just be 1/2 e to the u. And then we just add that constant for indefinite integrals, and we replace u again with our x squared. So we get 1/2 e to the x squared plus c. Today, we're going to look at this example. What happens if we're asked to do the integral x times e to the power of 6x dx? So we can't immediately apply any power rule, right? Because we have the product of two functions, x and e to the 6x, which are both x. And you can clearly see the derivative of 6x is not x. So we can't use substitution either. So what we're going to do is something called integration by parts. And I'm going to derive for you what that means, integration by parts. So let's just pull up a separate screen here. So in this separate screen here, I'm going to go over the product rule. Right? Remember, we did the product rule for derivatives, and that was basically if you had some function which was a composite of two functions. So let's say we have f at x times g of x, and we want to find the integral of that whole thing. Well, it's going to be the derivative of the first function, f at x, multiplied by the second function, g of x. And then we're going to add that first function and multiply by the derivative of the second function. That's just the product rule for derivatives. But now what I'm going to do is I'm going to integrate both sides. So if I integrate the left side here, well, we just get back that original f at x and g of x. And if I integrate both sides on the both sides of the equation, on the right side of the equation, we can use a property of integral, where we have the integral of the first term plus the integral of the second term. So we're going to have the integral of f prime times g of x plus the integral of f at x times g prime of x, both with respect to x. Alright, so here I'm going to make a little substitution. So I'm going to say u, just to make things a little bit easier to see, u is going to be our function f at x. That means if I take that derivative du by dx, right, we get f prime of x, but I'm just going to take that dx and bring it up here. I'm also going to call v g of x, and take the derivative of v with respect to x, and we get g prime of x. And then I bring the dx up here. Okay, so let me insert these back into this equation here. Make it look a little bit better. So we have f at x times g of x, so that's uv, equals, we're going to have the integral of, we have f prime of x and g of x. So f prime of x, or if you like, f prime of x times dx is right here. So that's just du. And g of x is v. So we're going to take the integral of v with respect to u. And then we're going to add the integral of, here we have f at x, which is u. And then we have g prime of x times dx. G prime of x times dx is du. And if I simply rearrange this equation a bit, we're going to get the integral of u dv is going to equal uv minus the integral of v du. This is the equation we use to integrate something by parts. So let's go back to the example that we were doing, and I will rewrite that equation here. Integral of u dv equals uv minus the integral of v du. Alright, now let's look here. This x out in front, that x is our problem. So let me let u equal x. Therefore, du by dx is equal to 1, or rearranging, du will equal dx. That means that dv, I'm going to set dv equal to what's remaining here. dv is going to equal to e to the 6x times dx. And then I need to take the integral of both sides of this to figure out what v is. So v is going to be the integral of e to the 6x dx, which equals, alright, we're going to divide by the derivative of 6x, which is 6, so it's going to equal 1/6 times e to the 6x. We're not going to add our plus constant term here because we're just going to add that at the very end, because the constants will just add and give new constants. So when we're done the whole problem, we'll add our plus c. Okay, so now we're going to take these, and we have this set up so that this here is our integral of u dv. So what we have is x times e to this, in the exponent there, 6x dx. That's going to equal, okay, u times v. So it's going to equal x times 1/6, so that's x over 6, e to the 6x. And then minus the integral of v. V's over here. Okay, so we have the 1/6 e to the 6x du, and du is dx. Notice now this is a problem we can solve. Right, so we're going to write that equal to, so we have x over 6 times e to the 6x, and then this integral, again, the 1/6 we can bring outside, and then we simply divide by the derivative of 6h, which is 6, so that's going to give us minus 1/6 times 6, which is 36, e to the 6x. And now we can add our constant. So that is how you integrate something with parts. So I'm going to give you an example that I want you to try. So try this one. Try and find the integral of 3t plus 5 times the cos of t over 4 dt. And you're going to use this equation to integrate by parts. And you should get, when you're done all that, just to check your answers, 4 times 3t plus 5 times the sine of t over 4 plus 48 times the cos of t over 4, and then plus your constant c.